Okay, in this video I will try to explain the basic fundamentals of tensors. So as usual, first let's set the timer for 15 minutes and keep it aside. Okay, the timer has started. And, let's also open a document and list the topics we are about to discuss today. TensorFlow series second video. So first topic will be what is tensor, and then we will look into creating tensors. Then we will check about some tensor attributes or methods, we can call it as. So in this entire series we are going to use a ID called collab notebooks. So we can access this by reaching this link collab.research.google.com. This collab notebook is a kind of a cloud ID provided by Google, so which is completely free, and also we can use this notebook only with browsers. So also there are other methods we can use this, but later we will look into those. But for now and for this entire series we are going to use this notebook in the browser only. Okay, so I already created a notebook, but let's create a new notebook, and let's create a notebook and give it as title. Okay, it is created, and so this notebook is completely free, and this is offered by Google, as I said, and all the backend will be provided by Google. So Google is good enough to provide us the free backend for this, and also we can use a GPU if needed in this backend as a service. But we will check that in later parts of the series. So first let's try to connect the backend to Google. Okay, this is connected, and these are the information of the backend RAM and the disk space provided to us to use this collab notebook for this instance. Okay, so if you are first logging into this collab.research.google.com, you probably need to log into this one with a Google account. So after logging in, we can use this. There are two kinds of cells we are going to use. One is a code cell, another one is a text cell. So this is a text cell. So here we can use the markdown languages and those scripts. Here we can type the code or whatever we are going to type in a Python language. So we can delete the cell by using this thing. Okay. First, let's check what is a tensor. Okay. So tensor is nothing but another kind of a data structure in Python, just like a string, set, list, dictionary, array, and an integer. So just like string, list, dictionary, integer, set, whatever we can say, whatever the different data types we are having. So we can call it as it in that way. Okay. we know that string is we know all about us what is a set, integer, or a list, or string, dictionary, everything. So tensor is more of a multi-dimensional array. So if you don't know about array, it's more of a list thing. In other languages like Java and C, we have this array, but in Python we have only this list. We can also use the array and its own functionalities with the NumPy library. Like, NumPy, we can use it, and also let's import TensorFlow. So with the help of NumPy, we can create arrays in Python. So with the help of TensorFlow, we can create tensors objects. Okay, aside tensor is nothing but a multi-dimensional array. So let's check how we represent a value or a variable uh, in an integer or a float thing. So if the object doesn't have any dimension, then we call it as a scalar. So we can call height 160 centimeter as a scalar value. So this doesn't have any dimension, so it's a zero dimension value, so it is a scalar. And we know that if it has a single dimension, so if it is traveling in a single dimension, if that's one dimension, then we can call it as a vector. Vector is in single dimension mean, I mean it's a list or array, whatever it is. So here I have created a list and I have created a NumPy array. Both are in the same, both are almost same, but the attributes and the methods inside the object list and the NumPy array object will differ. So yeah, this is a list and this is a array. Similarly, we have seen that a single zero dimension value as a scalar and a single dimension value as a vector, and if it has a two dimensions, then we can call it as a matrix. But we don't have any objects such as matrix in Python or most of the languages. To create a matrix, we can use either a list or a NumPy array itself, like matrix and b dot. We can pass this matrix as a thing, or we can also type this into this brackets. Okay, here I have created a matrix like it has a 2 cross 3 matrix, like it has a two two rows and three columns. Maybe we can represent it like this. So this is how the matrix will be represented in as a list or a array. So first matrix is this one. Then I have typed matrix 2. So matrix 2 is a NumPy array, so it is bracketed with the array thing. Then I have checked the length of the matrix. So obviously it will length object will with list will consider the outer elements. So this is the first element and this is the second element. So length of this matrix is 2, and the NumPy array we created with a variable matrix 2. It has a method with it has a property called shape. So it will tell us the shape. It doesn't list doesn't have that shape property. So NumPy array has this shape property. That's the difference. Some of the difference between using the list and NumPy array. Like in NumPy arrays, we have more control or more properties and more methods to perform some critical operations. So that's the main main reason of using a NumPy array instead of a list in some cases. So here I have typed the shape. So here we could see that matrix is created with a shape of 2 cross 3. Like there are 2 rows and 3 elements. 2, 3. So this is a matrix. Likewise, we have seen that a single dimension as a vector and 2 dimension as a matrix. Like it has a row and it has a column. And what if we needed to create a n dimensional array? Then maybe we can also use the NumPy array in a similar splitting this values in a n dimension. But the operations we need to perform on those arrays might have some restrictions. So here where tensor comes in. So tensor is a kind of an object or a data type similar to this list and arrays. It has its own properties and attributes and methods to do some more complicated functions and do more mathematical related operations to those n-dimensional object. Okay, so that's why we are going to use tensors in most of the deep learning related things. Okay, that is what tensor is. Let's check the second topic we are about to discuss today. Like, creating a tensor. So we have different methods in creating a tensor. So every time we have to use this object TF, use this TensorFlow to create a tensor. In most of the real world cases in creating a model in deep learning, we don't have to create a tensor. Just we have to load the data with the help of TensorFlow. Then it will convert the tensors, convert the data into tensors by itself. But for this tutorial, we will check how to create tensors. Okay, so tensors are built upon NumPy, so we can easily convert a NumPy array or any other list or a string, sorry, not string, but a list or integer or float values to tensor easily. Like first, let's create a scalar. Scalar value means we can call this variable as a scalar. Okay, scalar is 1. So yeah, this is an integer. Let's check the type of the scalar. Then it is an integer. So we are going to convert this integer into a tensor. As I said, in tensor we can create an n-dimensional object. So which means we can also create a 0-dimensional object. So 0 dimension is nothing but a scalar. It doesn't have any dimensions, as I said earlier. So tensor 0 we call this one. Okay, to convert this as a tensor, most of the time to create a tensor we will be using this thing, tf.constant. And one good thing about this IDE, as I said, this collab IDE is that it already come with a pre-installed packages with the latest versions. So we can check this version of this TensorFlow we are using. tf dot. So currently, while recording this video, the version of this TensorFlow, the latest version is 2.610. And this ID will be automatically updated with the latest versions of the packages. So most of the packages will be readily available in this ID, so we don't have to install any of the packages here. Okay, and also it has this autocomplete and other major functionalities which we use in normal ID like PyCharm or Visual Studio Code. So for creating a tensor, we will be using two major methods. Like one is creating a constant tensor, and another one is creating a variable tensor. But as I said, while doing a real world operations, we don't have to mention this whether this tensor is a constant or variable. So the TensorFlow is smart enough to figure it out itself what kind of tensor it is going to create. So first let's create a constant tensor. Here I am passing the scalar, this integer. So let's check what is tensor 0. tensor 0 dot dimension. To check the dimension of the tensor, we can use this property ndim. Okay, then tensor 0 dot shape. Okay, yeah, so here first we have printed the tensor 0, so it has printed the tensor object. So this is how the tensor will be represented. It will be having a shape, it will be having a data type, and it will be storing the value as numpy. As I said, it is built upon numpy, so it will be storing the value as numpy. And while checking the dimension for this tensor, it is showing us a 0. Since it is a scalar, it doesn't have any dimension. That's the reason it's showing us a 0. Same applicable for the shape also. So it is a single, not a zero dimensional tensor, so it doesn't have any shape. So let's try to create a tensor with a one dimensional. Tensor 1 equal to def dot constant. Here we, as I said, for creating a zero dimensional tensor, we are using a string, integer or a float value. So creating one dimensional objects, we will be using a list or numpy array. So in this case, we will use a list. Tensor 1 dot ndim 1 dot shape. Okay. What happened? Aha, constant it is. Yeah, tensor 1 has been created. So here we could see this tensor object here. So the list we have created, and the n dimension. So the dimension is single dimension, so that's the reason we are seeing this one. And the shape of this tensor is the kind of length of the list. So the 3 is the shape of this tensor. Let's create a two-dimensional tensor. Df dot constant. For creating a two-dimensional tensor, we will use the already created two-dimensional object. So maybe we can use this matrix 2 or matrix itself. So okay, here we have printed the tensor 2. So this is the tensor 2 object we have created, and the dimension of the tensor is a 2 dimension. So it has a row and a column. So that's the reason we are having this as a 2. And the shape is a 2 cross 3. So it is the shape of that matrix. So 2 rows and 3 columns. And also there is a trick to find this dimension, like how many numbers are there in this shape. It will be represented as the dimension here. So yeah, let's create a three-dimensional, not three-dimensional, maybe let's create a four-dimensional or n dimensional tensor here. So I'll put it as a tensor n. So before that, let's create a n dimensional numpy. Okay, let's see how to create a tensor with the n dimensional n dimensions. Constant, yes. Here we can use a list and convert split that into an n dimension, or if we want, we can also give the value as the splitted one. For the ease, let me put this as a let me put this. Okay, it already ended anyway. Let's just finish this topics. Okay, maybe we can use this np dot range function. So np dot range is nothing but a kind of a range function in list. we use while using creating a for loop. Maybe we are using that list range of some numbers, right? So np.arrange we can use 100. So this will arrange a list with starting from 0 to 99. So that's the purpose of this np.arrange. Let's see how it works. np.arrange. Mm-hmm. Yeah. So this is how it will be created. So we have 100 elements in a list. So that's what it will do, and we will put a shape here. So here we know that the shape represents the dimension. Like if the shape has two values, then the dimension is 2. So maybe we can create a four-dimensional tensor. For that we have to represent the shape here, 4 values, and the multiplication of the 4 values should have the result of 100. Then only this 100 will be split into that 4 dimensions. Like this tensor this object has 6 values, so multiplying this 2 into 3 will be providing this 6. So that's what I mean. So we have to use this 100 values. So multiplying the 4 shapes will should be resulting in that 100. So what we can use, maybe we can use 5 into 2, 5 into 2, 10, 10 into 10 into 2, 20, 20 into 5. Okay, 20 into 5, 100. Tensor again, let's look. Aha, the spelling. Sorry. Here we have to put the comma. Yeah, so we have successfully created the tensor with 4 dimension, and it has a shape of 5 cross 2 cross 2 cross 5. So let's check its dimension. Tensor n dot n dim n dot shape. So it has a 4 dimension, and the shape of this tensor is 5 cross 2 cross 2 cross 5. So it will be like multiplying these values should be resulting in the length of that list we have provided as input. So 5 cross 2 is 10, 10 cross 2 is 20, 20 cross 5 is 100. So we have successfully utilized this 100 values. What happens if we are not using all the values? Then it will be throwing some error there. Yeah, so this is how it will be. So yeah, this is how we'll be creating an n-dimensional tensor here. Sorry. Now let's look into another method of creating a tensor, like a tf dot variable. Variable. Here we have to use this capital V, and let's pass some values. 1, 2, 3, 4 maybe. So since we created this tensor with the tf dot variable, it doesn't have most of the properties as a tf dot constant. So like it doesn't have this dimension property, since this can be varying. So some of the properties are not available in this tf dot variable. Why we are using when we need to use this tf dot variable is like when the tensor need to be changed, like this has this property like assign. So we will change the first value of this tensor. So tensor variable 0 dot assign, let's put 0. So I have replaced the 0th element with the number 0. So we can see that 0, 2, 3, 4. So this assign method is not available in objects created with tf dot constants. So this cannot be edited after it was created. So that's the difference between creating a tensor with the tf dot variable or tf dot tensor. Sorry, tf dot constant. Okay, now let's look into another types. And before that, let me also show you how to define a data type while creating tensor. Maybe we can use the same thing, but instead of copying, we can write so that we'll get more practice. N1 we can call this dot constant. Df dot constant 1 2 3 4. It has 4 values. Shape can be 2. Sorry, 2 comma 2. And data type. Data type we can define the data type here. So let me set the data type to. We can use mostly tf dot data type here instead of a normal typing normal st or integer, something like that. So tf dot data types has more customizable data. Like if I want to give a float, we have this float 16, float 32, float 64. So these are nothing but a precision of the float. So 16 will consume low memory and it will have while doing some more complicated computations, this can save the memory and time when we use this float 16, but the accuracy might be a bit low. So float 64 will have more accuracy, which means it will be storing more of the values after that dot we are providing. So maybe float 16 we can use tensor n1 tensor n1 dot d type. So here the tensor object was created with float. Here we could see the dots, and the data type here we could see it has a tf dot float 16. So that's another thing we can provide while creating a tensor. Okay, let's come to the next topic. So what are the other methods we have to create a tensor? So if we want to create a tensor with random distributions, so this can be helpful in creating initializing weights while creating a model. Maybe we will look into that topics in a different video. But let's consider that we want to create a tensor with the random values. So for creating this tensors from random values, we can use this tf dot random dot from what distribution we are going to pull this random value. So first we will check from normal distribution, we will create a random tensor. So here we have to define the shape of the random values. Shape can be 2, 2 for simplicity. And yeah, here we could see the values are more random, and it has been pulled from normal distribution. If you have doubt in what is normal distribution, you can always Google it. Let's check the images. So this is how the normal distribution will look like. And let's create the same random tensor with the uniform distribution. Random dot uniform. Here also we have to provide the shape. Maybe I will put it as 3, 2. Sorry. Here the tensor has been created with 3, 2 shape, and the distribution where the values has pulled are from a uniform distribution. So uniform distribution. So this is how the uniform distribution will look like. So this is a normal distribution, and this is a uniform distribution. And if we execute this again, the randomness will continue, like the random values pulled from will be pulled from the, I mean, every time the values will be more random and random. But if we want to keep it as a same value while we executing it as the first time, then we have to set the seed. Tf dot random dot set seed. Maybe here we can give whatever value we want, like 7. So it is like asking the TensorFlow to keep the random seed as 7. Like we are instructing the TensorFlow to pick the random values from a normal distribution or a uniform distribution, but it has to use this value to pull that random values. So if we set the seed to some values, then the same output will be repeated every time when we execute the cell. Let's see. So now we have executed that cell. So here we could see that 8323 values. If I execute it again, then the same values 832304, it will be repeated again and again. So why we need this kind of a set seed is like when we're creating a deep learning model, and we are creating a randomly distributed weights initially. So and we have trained the model for some time, and it has been showing some good results in after 5 epochs, which means starting from this random values, it took 5 epochs to attain the maximum accuracy. But if we execute that code again after clearing it from memory, then if we execute that same random thing again, then the weights initialized will be different values. So then the epochs might differ from starting from different values to obtain maximum accuracy. Then the epochs might differ, and it might take more time to train the model, or it may also take the less time to train the model. So it depends. So we want to keep this randomness as repeatable, so that's why we set seed. So if we set seed, then the randomness will repeat. If we look here, it will be changing every time when I execute the cell. Okay, to execute the cell, we have to press shift plus enter. So that way we can execute, or else you can also click this run cell button. Okay, this is how we will be creating a random tensors. Let's look into some of the final methods. So it's already 30 minutes. Okay, we can also create a tensor with full of zeros or ones. So tensor zeros, for creating a tensor full of zeros, we can use zeros. Here also we have to give the shape to fill the zeros. 3 cross 3. So this is how we will be creating a tensor full of zeros. To create a tensor full of ones, mm, 2 cross 2 maybe. Okay, here the tensor has been created with a full of ones. So this is how we create a tensor full of zeros and tensor full of ones. So with this, we almost covered most of the major types of creating a tensor and converting a string, integer or a numpy array into a tensor. Okay, so I guess this is enough, and we will look into remaining topics in next video. Maybe what is the remaining topic means tensor attributes. Tensor attributes is nothing but some of the functions, some of the methods and properties we use from tensor. Like I have checked that tensor ones dot shape. This is an attribute of a tensor. So the, numpy arrays also has this attribute, and tensor ones dot random. This is another attribute. Ones dot what else we have? So there are different things we have, but let's check its size. Tf dot size. So these are some of the attributes of the tensors. Like we can check the shape of the tensor, so it is 2 cross 2, and we can check the n dimension of the tensor. So in dimension it is 2, and the size is 4. Size is nothing but the elements present in that tensor. So there are 4 elements there, so we are getting the value as 4. So if we want the output of a tensor to be integer or something like that, so if we want this as just a 4 instead of this whole object, we can use dot size tensor 1 dot numpy. Yeah, with this method we can get the absolute values here. So as I said, TensorFlow is built upon NumPy, so it can be both interchangeable from NumPy to tensor to NumPy things. So to get the absolute value, we can use this one, and also we can get the from all objects. We can use this NumPy statement, NumPy method. So this will be converted into NumPy array. So this tensor will be converted into NumPy array. Tensor 0 is a scalar, right? So let's also convert that into NumPy. So here we are getting the absolute value. So the tensor is 0. What is tensor 0? Yeah, it is a 1, and we got that absolute value here instead of getting the full object. Okay, I think we have covered almost all the topics we have discussed here. What is tensor, creating tensor, and tensor attributes. And we will look into more of the tensor operations in upcoming videos, and furthermore deeper dive into the TensorFlow. Okay.